We've explored many different properties of trigonometric functions, and now we can take this a step further and derive some identities. But first, what is an identity? An identity is defined as a statement that is true for all values of the input on which it is defined. And one such example is the Pythagorean identity. And that's what we're going to talk about in this section. The Pythagorean identity comes from the Pythagorean theorem that says a squared plus b squared equals c squared. Or if we're in a circle, we've seen x squared plus y squared equals r squared. We can manipulate this by dividing each side of this equation by r squared to get x to the second over r to the second plus y to the second over r to the second equals r to the second divided by itself. Now, another way to write this would be x over r squared, the quantity squared, plus y over r, the quantity squared, equals 1, because r squared divided by itself is 1. Now, why write it like that? Well, because we know that the cosine of an angle, any angle, is equal to x over r. And we also know that the sine of any angle is equal to y over r. So x over r can be replaced with the cosine of theta, and we'll square that. And y over r can be replaced with the sine of theta, and we'll square that. And that is equal to 1. This notation is more commonly written as cosine, with the square between the cosine and the theta. But I want you to just know that what cosine squared theta, what that means is just take whatever the cosine of theta is, whatever that output is, and square it. So cosine squared theta plus sine squared theta is equal to 1. Now, that theta is simply a placeholder for an angle input. If we have an angle input of t, then we might say that the Pythagorean identity states that for any real number angle t, that the cosine squared of t plus sine squared of t is equal to 1. Now, one thing to ask ourselves is, does this really work? And does it really work for any angle? Well, let's try an example. Let's say that t is equal to, let's say, pi over 6. And I'm using pi over 6 because it's one of our common angles. So here's what the Pythagorean theorem, or excuse me, the Pythagorean identity says. It says that if I do cosine squared of pi over 6, and I add that to sine squared of pi over 6, that it should equal 1. I'll put a question mark there because we're testing it out. So before I can square the cosine of pi over 6, I need to determine what is the cosine of pi over 6. The cosine of pi over 6 I have memorized as the square root of 3 over 2. So I'm going to take that value and square it. And the sine of pi over 6 is 1/2. So I'm going to take that value and square it. And I want to determine, does that equal 1? So the square root of 3/2 is equal to, and squaring that is square root of 3 times square root of 3, which is 3, and 2 times 2, which is 4. That's squared. 1/2 times 1/2 is 1 times 1, which is 1, and 2 times 2, which is 4. And I'm feeling pretty good about this because 3/4 plus 1/4 is 4/4, which is equal to 1. And so the identity checks. Now that's only for one value, but I guarantee you could put in any angle measure and find its sine and cosine, square them, add them, and it should equal 1. Now we have another way of finding the sine or cosine of an angle. So let's go back to an example that you may have seen me work out previously, where the cosine of t was equal to 24 over 25, and the angle t was in the fourth quadrant, and the instructions asked us to find the sine of t. So we're going to use the Pythagorean identity, and I would urge you as much as possible to copy that identity down, because the more you write it down, the more it might sink into your long-term memory. So Pythagorean identity says cosine squared t plus sine squared t equals 1. Now, you may recall me working this before, where instead of doing it with the Pythagorean identity, I said something like the cosine of t was equal to 24 over 25, and I let the 24 equal my x value, and I let the 25 be my r value. And then I used the x and the r to find y, and then I used y over r to finally determine what the value of sine of t is. So this is similar, but a little bit different. Not as many multiple steps, but I do have to work with fractions, so pay attention to that. Now, what the cosine squared of t says is that I'm going to take whatever the cosine of t is, which has been given to me, and I'm going to square that value. Now, the reason I tell you that is because a lot of people make the mistake of actually substituting in 24 over 25 for t. But t is not 24 over 25. Cosine of t is 24 over 25. So in the place of this cosine of t goes the number 24 over 25. And I'm going to take that number and I'm going to square it. Plus sine squared t, which I don't know, is equal to 1. So I'm going to put into my calculator 24 times 24, which is 576, and 25 times 25, which is 625. And I'm going to write this out again. I want to make sure I'm showing all my steps. And then I'm going to subtract 576 over 625 from 1. Now, of course, I'm going to use a calculator, but I'm thinking of 1 in terms of 625 over 625, right? So you might think of this as 625 over 625. And the reason I think of it that way is because now I can actually subtract 625 minus 576 is 49 over 625. And I'm going to square root each side to find out that the sine of t is equal to plus or minus the square root of 49, which is 7, and the square root of 625, which is 25. Now the final decision here is it the plus or is it the minus? And that's the purpose of, at the very beginning, being told that the angle is in the fourth quadrant. If you think about a circle and the fourth quadrant, in the fourth quadrant, let's just draw ourselves a little circle here. In the fourth quadrant, in quadrant 4, we know that any ordered pair are going to have positive cosine and negative sine. So positive cosine and negative sine. So if I'm in the fourth quadrant, then that means that this answer for the sine of t is going to equal the negative version of this answer. And if you go back to some of my previous videos, I hope that you see that I got the same answer. In addition to the Pythagorean identity, it turns out that there are two alternate forms of the Pythagorean identity. And here they are. The Pythagorean identity states, as we've seen, that for any real number or real number angle t, that cosine squared t plus sine squared t is equal to 1. Or an alternate form is 1 plus tangent squared t is equal to secant squared t. Or cotangent squared t plus 1 is equal to cosecant squared t. Now, That's a lot to try and memorize, so I want to encourage you to know that you don't have to memorize it. In fact, what I'd like to do instead is show you how we can derive those alternate forms ourselves. So let's start up at the top with the original Pythagorean identity, and let me show you how you can get those alternate forms. For the first one, if I take and divide each side by cosine squared t, so I'm going to divide the left-hand side by cosine squared t, and I'm going to divide the right-hand side by cosine squared t. Well, here's what I get. This cosine squared t, it divides into each one of these terms, right? That's just normal rules of arithmetic. So I get cosine squared t divided by cosine squared t plus sine squared t over cosine squared t is equal to 1 over cosine squared t. All right, that's a lot. But I think this will simplify quite nicely. Cosine squared t divided by itself is equal to 1. Plus, we know that the ratio of sine to cosine is tangent. And just because it's squared, as long as both of these are squared, we'd have sine of t over cosine of t times the sine of t over the cosine of t. So this becomes tangent squared t. And 1 over the cosine of t, we know that that reciprocal function is secant, and since it's squared, we can call this secant squared t. And that matches that first alternate form. So we've taken care of that. Now let's go to the other alternate form. And now instead of dividing by cosine squared t on each side, I'm going to divide, I bet you can guess what I'm going to divide by. I'm going to divide by sine squared t. And I'm going to do that on the left, and I'm going to do that on the right. And using that same rule of arithmetic, this sine squared t belongs to each one of those terms. So I'm going to get cosine squared t over sine squared t plus sine squared t over itself equals 1 over sine squared t. So cosine over sine of an angle is cotangent. So this becomes cotangent squared t plus sine of an angle divided by sine of an angle is 1. And finally, 1 over the sine of t, that is the reciprocal function cosecant. So this becomes cosecant squared t. And that is the same as the second alternate form. I would say don't necessarily memorize those alternate forms, but just know that if you have memorized the Pythagorean identity, that if you divide both sides by cosine squared t, or if you divide both sides by sine squared t, that you will have those alternate forms. So the Pythagorean identity, along with the fundamental identities that we've seen earlier, that are derived from the trigonometric functions we've already seen, can help us to simplify other trigonometric expressions. So let's look at an example. A, evaluate the cosecant of 7 pi over 6. So I'm going to write down the original problem, the cosecant of 7 pi over 6. That's going to equal, I see here that the cosecant is equal to 1 over the sine. So that equals 1 over the sine of 7 pi over 6. And let's see, what is the sine of 7 pi over 6? I know that it has a reference angle of pi over 6. I know that it's in the third quadrant. And so that makes the sine negative. And I know that the sine of pi over 6 is 1/2. So this has got to be negative 1/2. And when I simplify that, I get -2. All right, so the cosecant of 7 pi over 6 is equal to -2. Part B, simplify the tangent of t times the cosine of t. The tangent of t times the cosine of t. So that's going to equal, let's see, the tangent of t is equal to the sine of t over the cosine of t, and I'm going to multiply that by the cosine of t. And that cosine of t is over 1, so the cosine in the numerator and the cosine in the denominator cancel out, and I'm left with just the sine of t. So that's one way of simplifying. So let's take a look at an example. If the secant of t is equal to -17/8 and the angle t is between 0 and pi, find the value of the other 5 trigonometric functions. So we are told the value of the secant of t. So the other 5 trigonometric functions are the cosine of t, the sine of t, the cosecant of t, the tangent of t, and the cotangent of t. And I started with the cosine of t because secant was given, and secant and cosine are reciprocal functions. So if secant is -17/8, then cosine is -8/17. Still both negative because reciprocal doesn't change the sign. It just changes the positioning of the numerator and the denominator. All right, so from here, let's see, what else are we being told? We're being told that the angle is between 0 and pi. So that told us that we were going to be in quadrant 1 or quadrant 2. But we just found out that the cosine is negative. And if the cosine is negative, then we cannot be in quadrant 1 because quadrant 1 has only positive sine and cosine. So we're not in quadrant 1, we are in quadrant 2. If we're in quadrant 2, that tells me that the sign is going to be positive, so I can already put that positive sign there just to remind myself. Now, there are several ways to go about getting the rest of these. We just saw the Pythagorean identity that said cosine squared t plus sine squared t is equal to 1. So we could definitely use that. We now know the cosine, so we could substitute the cosine of t in and solve for the sine of t. Or we could use the variation of the Pythagorean identity where we divided both sides by cosine squared t, and that gave us 1 plus tangent squared t equals secant squared t. Now, the reason I put that on there is because we were given the secant, right? We were given the secant of t, so we could simply just substitute in this -17/8. We could substitute that in, and we could solve for the tangent. And once we know the tangent, we know the secant, everything else will sort of unfold. I personally, if I feel pretty confident with my cosine of t, the -8/17, I like to use the original Pythagorean identity. And that's only because I prefer to really memorize one thing instead of two things. I may not have this variation memorized, although as you heard me say, it really just is derived by dividing both sides by cosine squared t. So I can come up with it easily if I'd like. The other way that I could go about this is I know that the cosine is equal to x over r. So I could use the fact that x is -8 and r is 17, and I could use that with the Pythagorean theorem to solve for y. Lots of different ways I could do this. I'm going to choose to use the Pythagorean identity, and in the place of the cosine of t, I am going to substitute -8 over 17, and I'm going to square it, plus sine squared t equals 1. Now, -8 times -8 is 64, and 17 times 17 is 289. All right, so I'm going to subtract 64 over 289 from each side, and I might use my calculator, or maybe instead of equaling 1, I'll think of this as 289 over 289, because then maybe I don't need a calculator. 289 minus 64 is 225 over 289, and I'm going to square root each side. Normally I would say plus or minus, but because I already know that it's positive because of the quadrant that I'm in, I'm just going to take the square root of 225, which is 15, and the square root of 289, which is 17, and that gives me 15 over 17, positive 15 over 17 as my sine value. So there's two of them. Cosecant. Cosecant of t is the reciprocal of the sine function. Sine was 15 over 17, so cosecant is 17 over 15. Bam, done with that one. Tangent. Again, if I wanted to, I could put in, I could use the variation of the Pythagorean identity and put in that -17 over 8 for secant. I could do it that way. Or maybe what I want to do, I'll just put another or here, or maybe what I want to do, if I feel pretty confident with my value for sine and cosine, I might remember that tangent comes from the sine divided by the cosine. So let's see, my sine is 15 over 17, and I'm going to divide that by -8 over 17. And so if I, instead of dividing by -8 over 17, I multiply by -17 over 8, the 17's cancel, and I'm left with -15 over 8 as my tangent. -15 over 8 as my tangent. And then finally, cotangent is the reciprocal of the tangent. So I'm going to reverse the numerator and the denominator to get -8 over 15 for cotangent. And I think I've got it. Again, I've showed you a couple different options. I didn't show you all of the options, but I mentioned them. You might go back and try the other options and see if you get the same answers.